Welcome to this lesson on algebra properties. Please make sure you have these notes in front of you so we can begin our lesson. My students, let's make sure we also update our table of contents. The learning objective for today says I can identify different properties of operations. On this slide, let's talk about some of the vocabulary. The first vocabulary word is called properties. And properties are statements that are true for any number. In this lesson, I want to introduce 6 different properties to you. The second vocabulary word is called equivalent expressions. And equivalent expressions are expressions that have the same value. So for example, 10 times 6 is one expression. This expression is also equal to 6 times 10. So the expression on the left-hand side of the equal sign is equal to 60. The expression on the right-hand side of the equal sign is equal to 60. Both expressions are equivalent because they're both contain the same value. So on the key concept slides, I want to talk about 6 different types of properties that you're going to see. So I'm going to move in on the first one that has a picture of the mirror. If you were to look in the mirror, you would see yourself, or you would see your identity. However, in math, I want you to use this concept and think about the identity properties. Alright, so let's go ahead and move over to the second column that has a picture of a school, a house, and a school bus. So what you pretty much do every day is you start at your house, and then you leave your house, and you go to school. At the end of the school day, you go from school, you leave the school, and then you go back home. This is an example of a commute. But I want you to use this concept and think about the commutative properties in math. So the last concept, let's go ahead and move over to where there's a group of people hanging out. So for this one, I want you to think about your group of friends or who you associate yourself with. These are the people that you group yourself with, or the group that you belong with. I want you to use this concept to think about the associative properties in math. There are 2 types of each properties that I've just discussed. So there are 2 types of the identity properties, there are 2 types of commutative properties, and there are 2 types of associative properties. That's why at the beginning of the slide I said there were a total of 6 properties that we're talking about. So let's use these key concepts to discuss the following examples. So the first slide I want to discuss is called the additive identity property of 0. So remember, a property is a statement that is true for any number. So here's my first example. I can have a number 4, and I can add it to 0, and that becomes 4, because 4 plus 0 is equal to 4. This is the identity property because I want you to think of this 0 as a mirror. The 4 looks into the mirror and he sees himself, or he sees his identity. This is a true statement. So this is a property because 4 plus 0 is 4. So this concept can work for any number. So let's take a look at g plus 0. G could be any number, so if I add g to 0, I get g. Once again, g takes a look in the mirror, which is 0. 0 is the mirror. G looks in the mirror and he sees himself, or his identity. So this is also a true statement. So once again, this is the additive identity because this has a plus sign. This is the additive identity because it has a plus sign. So I want you to think of the identity as the 0, or the mirror that this number or variable looks at. The second property is called the multiplicative identity property of 1. So it has the same exact concept as the problem that we talked about before, but the only difference is now we're talking about multiplication. So if I say 4 times 1, I get 4. In this case, the 1 is now the mirror. The 4 takes a look in the mirror and he sees his identity when we multiply. So 4 times 1 is 1. This is a true statement, which makes it a property. So this can work for any numbers. I can say g times 1. When g times 1, I get g. G takes a look in the mirror and sees his identity. This is a true statement. So this is the multiplicative identity property of 1. because we're multiplying in this property. We're multiplying in this property. And in this case, the 1 is your mirror. So I want you to think about why your mirror can't be 0 in this problem. How come our mirror can't be 0? And I want you to think about that. Our third property is called the commutative property of addition. So if you remember from the key concepts, a commute means to travel from one location to the other. So I can say this: A plus B is equal to B plus A. All they did was they rotated. Like I can say I went from school to home, from home to school. It has the same concepts as the commute idea that I introduced to you in the earlier slide. So this is a true statement. So let's plug in a number so we can see if this works. Let's say 3 plus 4 would equal to 4 plus 3. Well, this is a true statement because 3 plus 4 is 7, and 4 plus 3 is still 7. So this is a true statement. All that happened was the 3 and the 4 flipped. So this is the commutative property of addition.
Now it's time for good idea, bad idea. Good idea. Asking your parents if they need help making dinner. Bad idea. Telling your parents to clean up the mess in the kitchen after they cooked you dinner.
The fourth property is called the commutative property of multiplication. So it's the same concept that I've introduced to you in the last slide. The only difference is now we're using multiplication. So I can say A times B is the same as B times A. So just think of the whole idea of you commuting from home to school to home. You're still traveling the same exact distance. So this is a true statement. Let's plug in some numbers. Let's say 3 times 4 is equal to 4 times 3. So let's see if this is a true statement. 3 times 4 is 12, and 4 times 3 is 12. So that is a true statement. So this is an example of the commutative property of multiplication. The fifth property is called the associative property of addition. So this is the one where we had a picture of a group of friends. So I want you to think about this. If I have a group of friends like A plus B plus C, or a group of variables, I can say that A plus B plus C is equal to A plus B plus C. But the only difference is the groups are changing. So in this, on the left-hand side, B and C are friends. But on the right-hand side, A and B are friends. So just because the grouping symbols changed, this is still a true statement. So think of the grouping symbols as the groups of friends. On the left side, B and C are friends, and on the right side, A and B are friends. So let's use numbers to try and solve this. I can say 3 plus 4 plus 5 is equal to 3 plus 4 plus 5. The only difference is on the left-hand side, 4 and 5 are friends, and on the right side, 3 and 4 are friends. So let's solve this to see if we get the same answer. I'm going to do my parentheses first. So 4 plus 5 is 9. Drop down to 3. And 3 plus 9 becomes 12. On the right-hand side, I've got 3 plus 4, which is 7, plus 5. And when I add 7 plus 5, I still get 12. So that's a true statement. So it doesn't matter who's grouped together. The associative property of addition says if the groupings are different, your answer is still going to be the same. And our last property is called the associative property of multiplication. It's the same concept as the last slide I just showed you. The only difference is we're dealing with multiplication. So if I have a group of variables that say A times B times C, which is equal to A times B times C, I'm going to group B and C as being friends, and A and B are going to be besties in the right-hand side. So this is still going to be a true statement, even if I group them. Let's go ahead and prove that this is true using numbers. Let's go ahead and say 3 times 4 times 5 is going to be equal to 3 times 4 times 5. Let's go ahead and say 4 and 5 on the left-hand side of the equal sign are besties. And On the right-hand side of the equal sign, the 3 and the 4 are going to be besties on that side. So let's go ahead and solve it. In the parentheses, I've got 4 times 5, which is 20, and I'm going to drop down the 3. 3 times 20 gets me 60. On the right-hand side, I've got 3 times 4, which is 5. No, I'm sorry. 3 times 4, which is 12. Sorry. Drop down the times 5, and 5 times 12 gets me 60. So this is a true statement. So the associative property of multiplication says it doesn't matter who's grouped. If I'm multiplying them, you would still get the same exact answer.
Now it's time for good idea, bad idea. Good idea. Opening your presents with permission. Bad idea. Opening your presents without asking for permission.
So here are your got it problems. Go ahead and pause the video and complete these problems, and we'll discuss the answers in class tomorrow. Notice you've got 1, 2, 3, 4, 5, 6, 7 got it's on this page. So go ahead and give me an equivalent expression for each got it problem.